Hi, today we are going to be working on this inequality word problems packet. I want to show you an example and so you know how to do the rest of the packet. So example. Okay, so the first part of the packet, you are given a phrase or a sentence and you have to represent it with an algebraic inequality. So for example, if they say something like x, or let's do the sum of 2x and 3x is at most 10. Okay? So in this case, the sum of 2x and 3x does not equal 10. It can at most be 10. So it can be 2x plus 3x can be 4. 2x plus 3x can be 8. 2x plus 3x can be 10, but that's the most that it can be. It cannot be more than that. So you can't have something like 2x plus 3x equals 11 because the sum of 2x and 3x is at most 10. So to describe this as an inequality, right? There's a range of options. It could be 2x plus 3x equals 8. It could be 2x plus 3x equals 10. 2x plus 3x equals 5. So to describe the range of possibilities, we know that 2x plus 3x can never be bigger than 10. So 2x plus 3x is always less than or equal to 10. So to write this phrase as an algebraic inequality, we can write 2x plus 3x is less than or equal to 10. So that's what you're going to be doing for the first 4. After that, I would like to show you an example of what you have to do for the rest of the problems. So let's do number 5 together. So here you don't have to solve for anything, right? You just have to write the phrases as inequalities. Here you will have to solve the problems, and they give you 4 steps. Read carefully and underline keywords. Write a let statement. Determine whether to use less than or equal to, greater than to, or equal to, and write and solve the inequality. So let's look at number 5. If 5 times a number is increased by 4, the result is at least 19. Find the least possible number that satisfies these conditions. So I know it's a bunch of words, but we can do just a quick example of a number. What's a number? Let's pick any number. So for example, I want to pick the number 10. If I multiply 5 times 10 plus 4, my result, is this at least 19? Yeah, it is. So 10 is a possibility. Let's try a different number. Let's try 11. Well, let's do 5 times 11 is 55. 55 plus 4 is 59. Is this at least 19? Yeah, it is. So there's multiple answers, right? So we want to write an inequality that could help us solve for all of the possible answers. So I'd like for you to write this coming notes down. This you don't need to write down. So we know we have some number, 5 times a number. So we can represent this with a variable because we don't know what it is. Okay? So 5 times some number, let's say x, is increased by 4. So increase is a plus 4. And the result is at least 19. So I'm just underlining important words. At least means it cannot be smaller. Has to be as big as or greater than. which uses greater than or equal to. So there's our inequality statement. The least possible number that satisfies these conditions. Well, we have to solve for what's the smallest value x can be. Okay? We solve inequalities pretty much the same way we solve algebraic equations. We isolate our variable. So I subtract 4 from both sides. And then to get x by itself, divide both sides by 5. And x is greater than or equal to 3. So the smallest number x can be is 3. Right? It has to be bigger than or equal to 3. Can't be smaller than that. So that's how you do these problems. They get tricky the more you go. And then I would like for you to also work on the inequality word problem homework. Okay? It's very similar. And we'll work on just the word problems for today. Okay? I want us to get familiar with how to model word problems as algebraic equations. And then we'll talk about, hopefully this part will be review where we're dealing with the number line. But for now, I want you to work on all of the word problems up to page 6. Okay? I'll be coming around the room and helping anyone who needs help. So please ask me questions and help each other. And you have the rest of the time to work on this packet. Thank you.